Welcome to the Great Climate Change Debate. Hi, John. Thanks for agreeing to this debate. I'm excited to be doing it via videos, and I hope it makes it more interesting for people to follow along. I'm arguing the affirmative side, so I'm going to go first. Let me start by introducing myself and giving you some background as to how this debate came about. A little bit about me and my background. I'm not a scientist, but I am married to one. No, she's not a climate scientist. I spent 8.5 years in undergraduate school before finally getting a bachelor's degree and going to college. I have an MBA and I work as a sales engineer for a software company. John has a similar background. We can both read and write. We both have broadband internet connections, and we're both committed into digging into the facts, going back to primary sources when needed to reach agreement on data or analysis, or failing that, determine exactly where we part ways. Our goal is to keep this as reasonable as possible. We genuinely like each other and respect each other, and intend to keep it that way. Okay, John, let's start by defining our terms. What is climate? As we both know, weather and climate are not the same thing. Weather is a snapshot of atmospheric conditions over a short period of time, from minutes to months. Storms, El Nino, that sort of stuff. Then there's climate. Climate is the same thing, only different, i.e. atmospheric conditions over a longer period of time. This is the IPCC definition of climate. Okay, the IPCC is the Intergovernmental Panel on Climate Change. Their definition of climate is this. Climate, in a narrow sense, is usually defined as the average weather, or more rigorously, as the statistical description in terms of the mean and variability of relevant quantities over a period of time ranging from months to thousands or millions of years. The classical period for averaging these variables is 30 years, as defined by the World Meteorological Organization. The relevant quantities are most often surface variables such as temperature, precipitation, and wind. Climate, in a wider sense, is the state, including a statistical description of the climate system. In various chapters of this report, different averaging periods, such as a period of 20 years, are also used. John and I have agreed that this will be our working definition of climate. Okay, now that we have climate defined, let's move on to our first potential area of disagreement. A definition or description of climate change. I'll start by giving a description of climate change. John, feel free to object to this characterization, stipulate to it, or we can attempt to refine it before continuing. I'll go ahead and stipulate to the fact that the climate is always changing. In fact, I'll also stipulate to the fact that there are lots of factors that contribute to climate change. Sometimes with problems that are very complex, it helps to simplify some aspects of the problem to get a grasp on it at a more fundamental level. Let's attempt to visualize the Earth's climate and how it changes over time. Because climate is a statistical description in terms of mean and variability of variables, like temperature, precipitation, and wind, over time, that should make it easy enough to visualize. We have an X, Y, and a Z coordinate, and we plot 3 bell curves. The 3 bell curves represent the statistical means and the variability for temperature, wind, and precipitation. So we plot the temperature curve might be kind of pointing looking along the x-axis. The curve for wind might be sort of flatter looking along the y-axis. The curve for precipitation might be kind of regular looking along the z-axis. Obviously, the curves would have different shapes depending on the scale and the data. Let's pick a point in 3-dimensional space that represents the intersection between the 3 loci at a given time. So as each of the different measures changes over time, what begins to emerge is a sort of 3-dimensional space that is sort of an amorphous blob or ball. The shape and the location of that ball at a given time is determined by all of the different variables that make up the climate at that time. So if the ball represents the climate, then climate change can be represented by how that ball changes shapes and moves in space over time. John, how does that definition suit you? Please feel free to stipulate to this characterization, object to it, or refine it. If you're willing to stipulate so far, allow me to proceed another step or two before I hand our conversation off to you. Now, our climate ball is subject to way more than just 3 variables. Imagine that our climate ball is suspended in space by a bunch of ropes, and the ends of those ropes are being tugged on by people of varying strengths, whose strength not only changes over time, but also varies in relation to each other as well as other factors. Now, The people pulling on the ropes represent things like the composition of the atmosphere, the Earth's relative distance from the sun, the Earth's orientation toward the sun and its rotation, solar output, composition of the oceans, the currents of both the oceans and the atmosphere, the amount of polar ice, and biogeography. These factors are encompassed not just by the study of meteorology, but by geology and volcanology, oceanography, hydrology, ecology, agronomy, and marine biology, not to mention straight-up physics and chemistry. As the Greenland Ice Sheet Project put it, the Earth has a climate system that is, quote, characterized by complex integration and feedback. The sun and all the parts of the Earth, the oceans, the atmosphere, the land masses, the snow and ice masses, all life, and the inner core of the Earth are parts of this system. Changes in any one part of the system affect all others and ultimately result in climate change. In the nearly 4.5 billion years that the Earth has been here, our climate ball has moved and changed shape a lot. In fact, for much of the Earth's existence, the space occupied by the climate ball has been a space in which our species and most of the other species that coexist with us now could not exist. In the next half of the Earth's lifespan, before it's incinerated by our sun, it will most certainly return to shapes and places that are at least inhospitable and at most certainly incompatible with human survival. The current location and current shape, in geological time that is, so let's say roughly 10,000 years, of the climate ball is sort of the sweet spot for us as a species. Now, we are the most adaptable species the Earth has seen. With complex DNA, that is. Viruses are a lot more adaptive. But we still need to stay pretty close to that sweet spot in order to survive on this planet. Here's the proposition for which I'm arguing. I believe that it's reasonable to conclude that human activity is causing changes in the factors that regulate the climate, called forcing factors. These forcing factors are moving the climate ball out of the sweet spot. Additionally, I'm arguing that altering human behavior and advances in technology can ameliorate some of those changes sufficient to keep the climate ball in or near the sweet spot. Once again, our goal is to dig behind the talking points of our respective camps and dig down into the actual science and see where it takes us. John, all yours.